motion is saying, find the time of one complete oscillation when acceleration is equal to 2.4 meters per square second and distance from the fixed point is 1.2 meters. Roman number 2, when acceleration is 3.2 meters per square second and displacement from fixed point is 20 centimeters. Mark this one very well. Sometimes you will change it to meters. We have example 2, which says a particle with a simple harmonic motion has velocities 4.4 meters per second and 3 meters per second at distances 3 meter and 4 meter respectively from equilibrium position. And the questions here are number 1, that we should find amplitude, period, frequency, and velocity of the motion at x is equal to 0 meters. Now we shall start from number 1. Solution 1, Roman number 1. Given A is equal to 2.4 meters per square second and x is equal to 1.2 meters, what we shall do here, we bring in our equation for acceleration. From acceleration is equal to negative mu squared x. So we substitute here and we get our mu squared. We shall ignore the negative. Negative, we shall ignore it. Mark this one very well. So we ignore the negative sign. So we shall have A is equal to mu squared x. And we have our A, we have our x. So we just substitute. A is equal to 2.4 is equal to mu squared times x. X is 1.2. So through dividing, we shall have our mu squared to be equal to, divide this one, we shall get, when we divide this one, we shall get 1 point, actually not 1.2, we shall get 2. So mu squared is equal to 2. Now from here, we move on to get our mu by square rooting both sides. So square rooting both sides, we have mu is equal to root of 2. This mu is what we call the angular velocity, and from angular velocity, there is no way we shall fail to get the time for one complete oscillation. This time for one complete oscillation is what we call period t. Now if mu is equal to root of 2, we know that f, okay, from f, actually from mu is equal to 2 pi f, we know that f is equal to 1 over t. So we shall say is equal to 2 pi over t, where t is our time for one complete oscillation. Now we shall say t is equal to, make t the subject, of course we shall have mu divided by 2 pi. After equating mu is equal to 2 pi over t, we shall have t is equal to mu over 2 pi. So we substitute and obviously we get the answer. So mu is equal to root of 2 over 2 pi. So we get our t to be equal to root of 2 over 2 pi as our answer in seconds. Full stop. So this is the solution for our number 1 of equation, no, solution for Roman number 1 of question 1. So let us go to Roman number 2. You see where your potential is. So let us go straight away to number 2, but I have to give some hint in this Roman number 2. Remember, this x is in centimeters, so you have to change it to meters, and you do the same thing I was doing here. So let us go to number 2, Roman number 2. take home. So do this one, try your best. So let us go to 2. Question 2 is saying, a particle with a simple harmonic motion has velocities 4 meters per second and 3 meters per second at the distances 3 meters and 4 meters respectively from equilibrium position. So that we should find amplitude, period, frequency, and velocity at x is equal to 0. So what we shall do here, we go back to our equation for velocity that we have derived. From velocity, actually, let's use v squared is equal to mu squared into r squared minus x squared. Remember that v is velocity, this one is mu squared, which is the angular velocity, you square it. This is our amplitude, and this is the displacement from an equilibrium position. Now, we shall consider one by one. In the first consideration, we shall say 4 meters per second and its associated displacement, which is 3 meters. So we substitute. Mark this one very well. We shall substitute. We shall say case 1. Case 1. V is equal to 4 meters per second and its x is equal to, this is 4 meters per second, its x is equal to 3 meters. So we substitute here, we form our equation 1. Later on, we also substitute using case 2, we form our equation 2, and of course, we shall have 2 equations. So let's substitute this one, v squared, we shall have 16 after substitution. This one we have mu squared. We don't know the value of amplitude yet. It is one of the questions that we should answer. Minus, we have x squared. X squared, 3 squared, we shall have 9. There is no way we shall continue without putting this one to be our equation 1. Later on, we also put equation 2, and from there we do we can do division. It is now 2 equations, either simultaneous equation. Now this is the case 1. We go and consider case 2. Case 2, v is equal to 3 meters per second, x is equal to 4 meters. We also substitute in this equation, and we shall have v, it means 9 is equal to mu squared. We don't know our r, but we know our x, which is 4. So 4 squared is equal to 16. Equation 2. Now from here, how is this equation 1 and equation 2 be solved? Just that we get the value of omega and we get the value of r squared. Actually, what we shall do here, we divide equation 1 by 2. Dividing 1 by 2, dividing equation 1 by equation 2, we shall have 16 over 9 is equal to that one over that one. And in that case, you will see clearly that omega squared will cancel out, and we shall only remain with a function of r. In that case, we shall get the value of r, which is our question number 1. So dividing 1 by 2, we shall have 16 over 9. Be very vigilant here. Vigilancy. 16 over 9 is equal to, even if I don't write because they cancel out. So we shall have r squared minus 9 divided by r squared minus 16. Okay. Cross multiplication. Through cross multiplication, we shall have 9 being multiplied by the numerator of that one, and 16 multiplying the denominator of this one. So we shall have this our denominator on the left hand side will multiply r squared minus 9, and 16 will multiply r squared minus 16. So in this case, as I was saying earlier on, we shall have 9 times r squared. We have 9r squared. 9 times 9, we have 81, is equivalent to 16 times r squared. We shall have 16 r squared. 16 times 16, we shall have 256. So we have done away with this one. Now we go to simplification. We have to collect the like terms. R squared should be in the other side, and the other constant should be in the other side. If we decide to pull r squared to be this side, so we shall have 9r squared minus 16r squared is equal to negative 256 plus 81. Of course, when a sign crosses equal sign, it will change to the opposite one. That is why negative sign was brought to this 16r squared, because it has crossed equal sign. Just like 81, it changed to positive. Now from here, we shall have negative 7 after subtraction r squared is equal to this one. We shall have negative 175. Negative 175. Of course, we do division there. Divide both sides by 7, because our emphasis is on leaving r squared to be alone. So r squared is equal to, after dividing, we get 25. What we are doing is question 2, Roman number 1. So r squared is equal to 25, and when we introduce square root both sides, here we shall have r is equal to plus or minus 5. Remember, this 5 is in meters and is what we call the amplitude of the simple harmonic motion. So we put the standard unit of length, which is meters, to be our amplitude. We go to Roman number 2 of this equation 2. This Roman number 2 is asking us to get period t. Of course, period t, we get it from the angular velocity, which is omega. Now, we have to substitute this r that we have gotten in either equation 1 or equation 2, just that we get our mu. Later on, after getting mu, we get t, of which t is the period of the simple harmonic motion. So substituting r is equal to 5 meters in equation 1. Let us use 1. Substituting r is equal to 5 meters in equation 1. This is our equation 1. So we shall have 16 is equivalent to mu squared. Our emphasis is on getting mu. Into bracket, r squared, already we have r is equal to this. R squared is 25. So we shall have 25 minus 16. In this case, we shall have 25 minus 16 is equal to 9. So we shall have 16 is equal to 9 mu squared. And in this case, we shall have mu is equal to plus or minus, after dividing and getting the square root, we shall have mu is equal to plus or minus 4 over 3. So this 4 over 3 is what we called our mu. Now, because mu is never negative, we shall consider the positive value, which is 4 over 3. This implies that mu is equal to 4 over 3. And it is from here now where we shall get our period t. Period t is equal to mu divided by 2 pi. We get it from there. Already we have our mu. There is nothing can stop us from getting t. So we just substitute mu is equal to 4 over 3 divided by 2 pi. So let us substitute this one. Of course, we shall have t as being 4 divided by 6 pi, which is equal to 2 divided by 3 pi. Remember, t is time, so we put the standard units for time, which is seconds. So we would have gotten our period t, which is equal to 2 over 3 pi in seconds. Full stop. We go to Roman number 3. Roman number 3 is frequency. How do we get frequency given period t? This one is now easy. Of course, if we want to get frequency from period t, we shall say frequency f is equal to 1 over t. They are inversely proportional. F is equal to 1 over t, even t is equal to 1 over f. If any of them is asked, given the other one, you get the answer. So from here, we shall have f is equal to 1 over t. Our t is this one. So we just substitute, and on substitution, we shall have f is equal to 3 pi over 2. Don't forget of the unit. F, which is the frequency, is measured in hertz. So we put here hertz. So we go to Roman number 4 of question 2. I was supposed to leave this one also as take home, but okay, we continue and we finish. I should also leave no stone unturned. Next time I will give you take home. Let us go to Roman number 4, that we should get velocity of the simple harmonic motion at x is equal to 0. Actually, this x, earlier on we said, is the displacement of the particle from a fixed point. So if x is equal to 0, let us go to our general equation for velocity, which is this one, which is that one also. But we can use this one. So v, we just substitute, given v is equal to this one, v squared is equal to mu squared into bracket r squared minus x squared. Already we know our mu to be, where is our mu? Mu is here. And our r it is somewhere, r is here. So x is equal to 0. We just do substitution and we get our v. So v squared is equal to mu squared. So we shall have 16 over 9. Obviously, after squaring this one, into bracket r squared. Remember, r is equal to 5. So we shall have 25 minus x squared. X squared, remember, x is equal to 0. So squared of 0 is equal to 0. And in this case, we shall have r squared is equal to 16 times 25 times 25 divided by 9. V squared. So getting velocity v, we squared, we get the square root of So we get the square root both side. Getting the square root of both side, we shall have v is equal to also square root of this one. We shall have 4 times 5 divided by 3 being our velocity. So we can simplify this one to 20 over 3. And don't forget of the units of velocity. We shall have 20 over 3 meters per second, full stop. You will find that we have done all the examples 1 and 2, except Roman number 1 of equation 1, where I told you to do it from home. Now, thank you very much for listening. We as Molten Ite Educational Services commit ourselves to give you everything that you would love to get. Thank you very much.